In this lesson, we're going to learn about mesh current analysis. It is like so similar to node voltage analysis, but they are dual of each other. So let's study this method by this example. First of all, in this circuit, we are going to specify meshes. Each mesh is the complete loop in the region that we're going to consider. For example, this one is one loop, one complete loop, and it is mesh number 1. This one is mesh number 2, and mesh number 3. Also consider that by convention, we're going to draw them in the clockwise direction. So by clockwise direction, we can analyze the other steps that we're going to do. So after that, we are going to write KVL for each mesh. KVL at mesh 1 is minus VS1 plus VR1 plus VR2 equal to 0. What is VR1? Well, VR1 is R1 times I1 minus I3. Why? Because if you look at the resistor R1, the voltage across it and the current that are passing through are I1 in this direction and I3 in the opposite direction. So the overall current will be the difference of I1 and I3. That's why we have written in this form. So let me clear this part. And also VR2 is R2 times I1 minus I2. Why? Because similarly what we did for the R1 resistor, in R2 resistor here, we have two currents that are going through it. The first one is I1 in this direction, and the other one is I2 in the opposite direction. So the overall current will be the difference of it. That's why we have written in this form. Okay. Now, let's write it and organize it, the KVL at mesh 1. So it will be minus VS1 plus R1 I1 minus I3 plus R2 I1 minus I2 equal to 0. So this is our first equation that we have found. Now let's go to mesh 2. KVL at mesh 2. It will be minus VS2 plus R2 I2 minus I1 plus R3 I2 minus I3 equal to 0. This is the other equation. And similarly, KVL at mesh tree will be R4 I3 plus R3 I3 minus I2 plus I3 minus I1 equal to 0. So we have this equation number 1, 2, and 3. We have 3 equations and 3 unknowns, and we will find I1, I2, and I3 easily. So we will find each of them by these 3 equations. So now let's go to the other example and see more examples and how to deal with circuits with this method. In this example, we have current source in the circuit. So let's implement mesh current analysis method here. So let's consider this one mesh 1, this one mesh 2, and this one mesh 3. Always remember that they all should be in the clockwise direction. So what we see here, we can note that IS is equal to I3. So I3 is equal to IS, and this is known. So I3 won't be unknown variable. So we have found it here by checking the circuit. So we would have 2 equations. Therefore, we need to write 2 KVL equations. KVL at mesh 1. It will be R2 I1 minus IS plus R3 I1 minus I2 plus Vs equal to 0. And also KVL at mesh number 2 will be R1 I2 minus IS plus R4 I2 plus R3 I2 minus I1 equal to 0, like the previous example. So we have 2 unknowns and 2 equations, equation number 1, equation number 2, and we can find I1 and I2. We can find both of them. So let's go and look at the other example. Let's talk about this example. Here we have 2 inner meshes which are in the clockwise direction, mesh number 1 and mesh number 2. However, we notice that there is a current source between 2 meshes. In this case, we would use the modified version of the current source method. So whenever we have this situation, we will consider these 2 meshes as one super mesh. So we will have a super mesh in this direction, again clockwise direction. So we can call super mesh S, and we will write KVL for super mesh S. So KVL at supermesh S will be, okay, R1 and R2 are in series, so the voltage across them will be R1 plus R2 times I1. Since R1 and R2 are in series, the equivalent resistor of them will be sum of each of them. So that's why I have written this summation of them. And plus R3 I2 and plus the voltage across this dependent voltage source will be Rm Ix and equal to 0. So note that Ix is equal to I1. We can clearly see this from this mesh. This is the I1 and this is Ix, so it will be equal to each other. Therefore, we can write these equations as R1 plus R2 plus Rm, if we factor out I1 plus R3 I2 equal to 0. So this will be our first KVL equation. We also need a constraint equation. So whenever we have a supermesh, not only we would have KVL at supermesh, but also we need a constraint equation. So constraint equation will be I1 minus I2 equal to Is. Therefore, we would have two equations and two unknowns. Well, I1 and I2 are unknowns. So with these equations, we can find I1 and also I2. Now let's go see another example and learn more about it. In this example, we are going to find current I. So here we can see a current source which is going upwards 2 amperes is between two inner meshes. So let's call this inner mesh 1 and this one inner mesh 2 and this one inner mesh 3. As we can see, this one is between inner mesh 1 and 2. So we will have modified mesh current analysis and we will consider this loop as super mesh. So we will write KVL for super mesh one and 2. It will be 2I1 plus 4I1 minus I3 plus 12 plus 6I2 equal to 0. Because we know this one, this expression, is the voltage between the 2 ohm resistor. And for this resistor, we would have one current I1 in this direction, and the other one, I3, in the opposite direction. So we will have the difference of them, and we will multiply it by the resistance, and we will get the potential across this 4 ohm resistor. And similarly, also for the 12 volts batteries, we have written this 12, and for the 6 ohm resistor, we have written this one. So this is our first equation. Now let's look at the other equation that we might see. We can see that I3 is equal to minus 3Vx. I3 is in this direction. It is exactly opposite. This is I3. It is exactly opposite of this current, dependent current source. So we will have I3 equal to minus 3Vx. We also know that because of this expression that we have written here, the potential difference across this 2 ohm resistor will be equal to minus Vx. So we can say Vx will be equal to minus 2I1. Okay. From here, we can say I3 is equal to 6I1. This is another useful equation. This is the second one. And we also have a constraint equation. And it is I2 minus I1 equal to 2. So from here, I2 can be written as I1 plus 2. And this is the third equation. From these 3 equations, we can find 3 unknowns, I1, I2, and I3. So we can find I1 equal to 2 amperes. And if we know I1, we can find I3. I3 will be 12, right? Because I1 is 2 amperes. So if we multiply it, it will be 12. And it is enough. We don't need to find I2 because the question asks us about the I. So because I will be equal to I1 minus I3. Because as you know, let me write it in this red color. I1 is in this direction, and I3 is in the opposite direction of I1. Since the question says what is the direction of I, so it will be I1 minus I3. it won't be I3 minus I1. Be careful about it, because I is in the same direction of I1. So that's why we're going to write I1 first, then minus I3, not I3 minus I1. So after this, we can find 2 minus 12. 2 amperes minus 12 amperes, it will be minus 10 amperes. So we found I in this question. I hope that this video was helpful for students to understand and grasp the concept of mesh current analysis method. And thanks for watching.